Okay, and I will broadcast now. Great. Let's see if it looks like people can join. Yes, it does. Okay, great. All right, so in that case, I will just go ahead and get started. So welcome to everyone who's joining us to the Global Media and Policy Seminar Series. This is an online seminar series jointly organized between the Program in Comparative Media Law and Policy at the University of Oxford and the School of Communication at the University of Johannesburg. This series features insights on pressing issues affecting new media and human rights, especially at the margins. We live stream these talks online to help bridge the gap between conversations happening in the global north and the global south on today's most important media debates. So we hope you'll continue to join us for future seminars. You can sign up by visiting the PCMLP website or tune in live on YouTube at PCMLP Oxford, which I will put up on the screen now. Oops. There we go. Yep, that's our website and the YouTube accounts that you can access our seminars on. So today we'll be taking questions here on Zoom. You can use the Q&A feature, which is available in your Zoom window. And if you're watching the live stream on YouTube, you can tweet your questions to @Oxford Media Law, which you should be able to see on the screen right now. And I will be checking both of those locations for questions as the talk is going on. And that takes care of basically all of the logistics at the moment. So I will stop sharing my screen now. Just by way of a brief introduction, I'm Kira Allman. I'm a postdoctoral research fellow in media law and policy at the Center for Socio-Legal Studies at the University of Oxford. And today I am delighted to introduce Niels ten Oever, who is joining us for this seminar. Niels is a postdoctoral researcher at the University of Amsterdam and Texas A&M University. His research focuses on how norms such as human rights get inscribed, resisted, and subverted in the internet infrastructure through its transnational governance. Previously, Niels has worked as head of digital for Article 19 and program director for Free Press Unlimited. You can find him on Twitter or via his website, which I will put in the chat while Niels begins his talk. So with that, I will hand it over to you, Niels. Thank you so much for joining us.
Thank you so much, Dr. Allman and the two institutes for hosting me, and maybe even more older people that are watching live or later via other media. As Dr. Allman said, I'm Niels ten Oever. I'm a postdoctoral researcher at the University of Amsterdam and Texas A&M University. And today I will be taking you through the last two chapters of my dissertation called Wired Norms, Inscription, Resistance, and Subversion in the Governance of the Internet Infrastructure. So hopefully that will save you a bit of reading. If not, then you can always go back there and see what I actually meant and what I maybe have not told way too clearly today. So let's go ahead. What we will be looking at today is what some call the logical layer of the internet. And I'm quite fascinated in that, because if we ask ourselves, how is it possible that the internet, which is an internetwork of networks of 70,000 independent networks that are connected to each other without binding rules or regulations, mostly voluntary norms. Well, this is exactly what gets done on this logical layer of the internet in a plethora of bodies. So just like the internet infrastructure is distributed, so is its governance. So there is no central governance body. So while there is no central authority, that doesn't mean there is no power in the governance of the internet infrastructure. And I will try today to go into that a bit with you. And to analyze that, I have a model here for you. And this model is directly the test that I think or hope that you don't understand yet, but at the end of the talk, you should be saying something like, well, this is totally clear after Niels's talk. So let me shortly summarize it now for you, and then later we can run the test. So What this image is trying to express, that the internet socio-technical imaginary of the internet architecture is guiding and facilitating and legitimizing the regime ordering that is anchored in architectural values and process values that are actually subverted. But what really matters in the assessment and evaluation of new candidate norms and existing policy, technical, and institutional norms is the infrastructural norm of voluntary interconnection and interoperation. But we are not there yet. We'll get there to the end. Don't worry. So I'll start with a body that many of you might have heard of and some haven't. And that's not that weird, because it's the nature of infrastructure to actually hide itself. And even though it's shaping our modern lives and societies, it's often only looked upon when it's not working. And here we are looking at the body that is producing the internet infrastructure itself, the Internet Engineering Task Force, which has been meeting in different organizational constructs since the end of 60s, beginning of the 70s. And I look at the Internet Engineering Task Force because it is not easy to look at something the size of the internet. Does one need a telescope or a microscope? So this is not by accident that the field of internet measurement, just like the internet, is growing fast, because it's really difficult to measure and understand something that's that big. And of course, it is important to understand the shape and the structure of the medium, because it's not just the content, but according to Marshall McLuhan, it's the medium that is the message. And according to Keller Easterling, who also acknowledges that the infrastructure sets the invisible rules that govern the spaces of our everyday lives, but she adds that changes to the globalizing world are being written not in the language of law and diplomacy, but rather in the language of infrastructure. So if we want to understand the world, and maybe even ourselves, we need to try to understand this language of infrastructure. But if we do that, we should not fall prey to the trap of technological determinism. Technological determinism, of course, says that the uses of technology are largely determined by the structure of technology itself, because the internet is used in so many ways that was never envisioned, and it was everything never expected to work on a scale like this. So even the internet overcame its designers and its design and its technological materiality to become something else. But on the other hand, we should also not fall for the trap of social constructivism, which says that technology can be everything that is. We're always materially also a bit constrained. But it's important to understand technology, because we shape our tools and our technology, and thereafter our technology and our tools also shapes us. But to make it then even more difficult, infrastructure is not something that we can see on itself, because it's always related and embedded. This means that it's never just technology, but it's also the maintenance, the design process, the institutions, the money flows, the people, the relations, and the power that make all this possible. So when you look at an infrastructure, you should try to look at the network that's all making it possible. So we should look at even more things. And to do this, I try to leverage affordance theory, which then describes that technology is not completely determining its use, but it's enabling and constraining certain features that are possible or easier possible than others. So it's inviting a certain way of looking at the world. And then the final piece of this theoretical puzzle that we're going to attack the problem of the internet infrastructure with is a socio-technical imaginary. And I think we should really pay attention to Sheila Yazanov that when she develops this concept, because the socio-technical imaginary helps explain many of the things that are going on today. Because the social help people from different groups work together in the development of narratives, policy, technology, and institutions. So for this, it is possible to have people that have different backgrounds, different interests, work towards a common goal, that a concept has enough plasticity to translate to the social world of different groups, but also give people a common cause and to rally against. And then that results in a future that is then jointly shaped. I'll show you how that is the case in parts of the internet infrastructure, but you can also see that in a lot of new technical trends, for instance, about space, but also about the prevalence of algorithms and bitcoins, and it really can help critically examine these concepts, this concept of socio-technical imaginary. But back to the internet infrastructure, because where I'll be looking at is this institution, the Internet Engineering Task Force, in this first part, and they write down everything they do, and they have open archives, and that makes it a joy for researchers, because all their conversations and all their decisions have been archived and are publicly accessible. All the discussions have largely taken place on mailing lists and also in the same mailing list format. Same, the outcome documents, the so-called requests for comments, RFCs, are stored openly and freely available. So I've been looking at them to look at how this technology developed and what is the human part, the power part, the affiliations part, the relations part, to uncover that. Because standard setting is a very wild mix of politics and economics. It may be even more than the technology itself. So my theoretical framework is based on science and technology studies, international political economy, and a tad bit of international relations. So for this first part, I engaged in 25 interviews, the quantitative analysis of all roughly 9,000 RFCs, qualitative analysis of 25 RFCs, and quantitative and qualitative analysis of mailing lists of almost 2 million emails over 955 email lists, and participant observation over 4 years, so roughly 11 meetings. We can talk methods after, but let's first dive into the real meat of the issue. Because if you start looking at such a global group of people that produce the internet infrastructure, I was very interested what the different values were of all the different groups and people represented there. Because I thought, how do these people work together? And especially when a group exists for longer, it is more common that, or it happens often that then values are a bit more divergent than in the beginning. But this is not what I found in the Internet Engineering Task Force. Both in the quantitative and the qualitative analysis, I found 3 values coming back again and again and again and again. And because they are so prevalent, I want to introduce them to you. And the first one is the end-to-end principle. And the most technical conception of the end-to-end principle says that the intelligence of the network is at the edges, and that the network, that is the internet, only provides transports to packets over the network. And this makes for the network to have a relatively low complexity, but also a high robustness. But at the same time, this is not just a technical conception. There is also a social political conception to the end of the to the end-to-end principle. And you can see it here in RFC 1958, where it says that the goal of the internet and its community is connectivity. The tool is the internet protocol, and intelligence is end-to-end rather than hidden in the network. So that means that the power is at the edges with the people that use the network. And in another RFC, it said that all hosts, all computers on the internet are equal. But if you then look in other ways that come forward when you engage in participant observation, you see that also on one common place where people express themselves is their t-shirts, that political and financial considerations are very, very, very common here. Also in the end-to-end principle. And you do not only see that on t-shirts and in snarky comments, but you even see it in their official policy documents, in this case, even in the IETF's mission statement. Please read with me this final paragraph. The internet isn't value neutral, and neither is the IETF. We want the internet to be useful for communities that share our commitment to openness and fairness. We embrace technical concepts such as decentralized control, edge user empowerment, and sharing of resources, because those concepts resonate with the core values of the IETF community. These concepts have little to do with the technology that's possible, but much with the technology that we choose to create. Well, this sounds more like the battle cry or the motto of a group of radicals rather than an industry self-regulation body that is comprised largely of transnational corporations, right? But nonetheless, this comes back again and again and again. So both in the discourse, spoken discourse, email discourse, and in the technical documents. The second concept that dovetails really nicely with end-to-end is permissionless innovation, which means that there are no barriers for the deployment of protocols between these endpoints. So the end-to-end principle says that the ends should have the control and that the network is there only for the transport between the packets, but the endpoints can also decide the way, the manner, the language, and the signs with which they want to communicate with each other. So they should not need to negotiate with entities in the middle of the network. We know this is a response to two things. On the one hand, there is the response to the telco era, because telecommunications companies had an opposite design of network, where the intelligence was in the network and the nodes, the end nodes, were dumb. As you might remember, phones, they only had 12 buttons or 11, 10 numbers, and then a hashtag and a star. So very little options, and you need to ask the network to give you services. Well, on the internet, it's the other way around. But also, and this is very important for you media scholars to not forget, is that the internet up to 1992 was a fully publicly funded project. And that meant that the internet backbone was run by the NSFNet, the National Science Foundation in the United States, that was publicly funded, which also meant that no commercial traffic was allowed on the internet. So up to 1992, the internet was a public project and there was no commercial traffic possible. So anytime someone says that the internet is this marvel of commercial enterprise, it's an outright lie. The third value that we get to is openness. The openness also, again, and you feel this coming, again, has very technical and social political connotations. The openness of the networks in its most technical definition means that any endpoint on the internet could be reached, should be reached without traffic being hampered, altered, or stopped. And this becomes very important later on. But also the ability to always add new endpoints to the network. So the internet was made for growth with internationalization in mind. And to do this, the development was open standards that are voluntary, so that these endpoints could decide what they're going to run between themselves. And the standards that are developed should be freely accessible. And then thirdly, is that the governance in all these bodies, all these plethora of governance bodies, should be transparent, have open archives, which allows us to do this research, but also have open participation. And this means that if you are concerned, or if you have a strong opinion, or maybe not even such a strong opinion, or just an interest in how the internet architecture and infrastructure gets developed, you are able to join these bodies. You only need an email address. So that might be interesting for you to do some research or some to satisfy your curiosity on a weekend yourself, maybe. So these three values together produce quite an interesting political environment, where the unofficial motto of the IETF is, "We reject kings, presidents, and voting, and we believe in rough consensus and running code." And this is, of course, completely different from previous global communication networks, such as the telecom and the telegraph, that were standardized in multilateral bodies, such as the International Telegraph Union or the International Telecommunications Union, which is now one of the oldest bodies of the UN, but was already established in 1853. Now, what is so interesting about is about these RFCs and about these discussions is something that Sandra Brahman brought forth when she read the first 1,000 RFCs. And Sandra Brahman is not a computer scientist, so she described this process sometimes as reading Martian upside down. But she did it and fully coded the RFCs, and she concluded that explicit discussions about rights and freedoms as well as social impact of technology have featured in the RFCs since the early beginnings. So it also, if anyone says, well, security and privacy and rights and freedoms were just not considered at the beginning of the internet, that only came later, that's simply, again, not true. It might have been the case that they were discussed and not implemented, but we'll get to that later. So as said, at the end of the 80s and the early 90s, remember of the context, the fall of the Berlin Wall, the Fukuyama's end of history, liberal democracy had won, and the internet was growing. The internet was growing fast, and so were the costs to run the backbone for the National Science Foundation. And a solution needed to be found for this. And there was a workshop held with Robert Cahin, who chaired it. And the question was, how are we going to deal with the with the growth of the internet? Several proposals were brought forward. We had like national funds that could fund the internet. We could set up our own institutions. And the other one was privatization. And of course, the answer of that workshop was privatization and commercialization. So that meant that the US government started ceding control. The ARPANET even was decommissioned, and slowly the NSFNet backbone was decommissioned, as well as the other networks that were running. And it was the establishment of commercial internet exchanges, and then also the formal institutionalization of the bodies that before that were informal working groups and task forces, but now became the formal bodies of the private multi-stakeholder internet governance regime as we know it today. Most notably, the Internet Engineering Task Force, which finds its home within the Internet Society. And in the second part of this talk, we'll talk a bit more about regional Internet registries. And then what happened at that first meeting of the Internet Engineering Task Force, after it was established independently in 1992, there is in the middle of the week always something called a technical plenary, and that's where everyone not comes together in working groups, but in one meeting. And there, a German statistician stands up, and somehow statisticians are always Germans, and he says, if we continue at this pace, we will run out of IP addresses within 2 years. And that means the internet could not fulfill on its promise of openness anymore. Because if you want to be on the internet, the most important precondition to be an endpoint is to have a unique number. And this unique number is your address, and that is called your Internet Protocol address, your IP address. So there were not enough IP addresses, and the replacement for new IP addresses was not done yet. At the same time, Steve Belovin, who invented the firewall, also made it clear that security considerations became more real on the internet when it was not longer comprised of only trusted actors. And network operators that were connected to these commercial internet exchanges were interested in differentiating their business models. So one answer to the problem that came up was network address translation, or in short, NAT. Practically, these boxes, these routers, are often called middle boxes because they sit in the middle between you and the network. And what they do is that, as you see in this picture, a NAT router has one public IP address, but within your home or corporate environment or otherwise, it provides several internal IP addresses. That is why if you know one IP address by heart, it's probably 192.168.1.1, because that's not a public internet address, because public internet address need to be unique, because else packets can't be routed to it. No, it's one behind a nut. And what this nut does is that it creates directionality. So every computer that is behind the middle box can still reach the internet, but the whole internet cannot directly reach behind that net, because not everything has a unique number. And this is why, and this is where the user was created, because all your phones and devices have much more processing power, disk space, and memory than web servers had for many years. But it's hard to run a web server or a mail server from your home, because you cannot make it publicly visible. So that is, in short, where servers were created, which was then also the start of consolidation of media empires. These the first networking protocol for sending each other messages, even before email, was called Finger, and it would allow users to directly connect with each other without a server getting in between and storing all the messages. So these nuts, these middle boxes, starting to do a lot of things to traffic that were not just making IP addresses less scarce, but they were also doing things to, for instance, peer-to-peer traffic. You remember the early rise of Kazaa and Napster? But internet service providers didn't like that, because that put a lot of strain on their network, and that made them need to invest more in expensive equipment and hardware. So the firewalls did not only have a security purpose, but they also had an administrative purpose of control. So this network management that started going on, that was brought up on the skies of quality of service and caching and prioritization of services, added a functionality to the network, but not at the edges, but in the core of the network. And this led to the network and these boxes that were in between, that were expecting specific kind of traffic, and traffic that they did not recognize, they would stop. And this meant that the network was slowly ossifying. And ossification is the process where bone is becoming harder and harder. And that's very good, because bones in the early phase can be very brittle. That's why kids often break their bones. But when it gets too hard, it breaks again very fast as well. So this new introduced directionality created users and producers, but also created a whole new affordance structure in the internet architecture. And as an example for this, it's really good. This was in the recent development of transport layer security. Well, many of you may not have heard about TLS, but you have all used it. So every time you visited a website that started with HTTPS, you use TLS, because the S stands for the TLS. But when the IETF wanted to develop a new version, namely TLS 1.3, it worked perfectly in the lab. For the connoisseurs among you, TLS 1.3 added forward secrecy to the protocol and included some elliptic curves. So what TLS 1.3 did on the network was fail. It failed all the time. And the engineers wouldn't understand why until they changed TLS 1.3 in naming to TLS 1.2. And then it worked perfectly. So this meant that all these not middle boxes in the network expected TLS 1.2, did not know TLS 1.3. So everything that announced itself as TLS 1.3, they would just say, no, don't know you, you're not coming in. And this means This ossification means that if we want to develop the future, it needs to look like the past. But TLS was actually very lucky. A project that was not so lucky was SCTP, the Stream Control Transmission Protocol, a protocol that was meant to replace one of the early internet transport protocols called TCP. So we had, I explained to you shortly what IP was. TCP is a transmission control protocol. It's not complicated whatsoever. It's made out of 3 parts. It's made out of SYN, SYNAC, ACK. And this is simply means, hello, I want to send a message to you. Thank you, that's fine. Okay, here it comes. So this is just a way in which two end hosts agree to share information with each other. But this was not very efficient if you need to ping pong back and forth all the time. And if you want to add security, you need to ping pong even back and forth even further. So the SCTP project wanted to make this more efficient. And they succeeded, just not on the internet, because it was blocked by many of these nuts that, of course, did not know of this protocol yet, because it was not developed yet. So from 2002 to 2017, people worked very hard on developing this protocol, but it never worked on the internet. And yes, they did blame the network, but not in vain, because then Google came along and started the development of QUIC, which, like SCTP, is a stream-based protocol, but developed by Google. And maybe in part by many of you too, because what Google did experimentally is use their control over the biggest browser in the world, Chrome, and their availability of servers around the world to test out this new protocol and see where it worked and where it did not work. And then it could make little adaptations. But this is called A/B testing, to see under what conditions and where a protocol would work, so that these endpoints could talk to each other. And if not, the protocol in the browser would fall back to TCP, so you wouldn't even notice. So this development of a QUIC kind of included a new form of TCP, which is called UDP, and UDP, where TCP needs to go, needs to confirm that, hi, can I send you something? Yes, you can. Okay, here I come. UDP is a bit of the annoying little brother who is just saying, I'm going to talk to you, I'm going to talk to you, I'm not going to talk to you, I'm going to talk to you, don't matter what, if you want to hear it or not. So it's just starting to send packets, and if you don't hear back, then after a while, it fails gracefully. Then it just goes home back to his room. So because it just sends packets and then also engages directly in encryption by default, there are much less steps back and forth. And this makes the protocol much more efficient and save much more latency. So that, of course, is great. But the reason that encryption was added here in default was not necessarily or solely because we had the Snowden revelations, but also because the protocol did not want to share any information with the network, because it knew from experience that the network would ossify around it. It would try to hold on to it. So what QUIC did is that with encryption, it tried to grease as much of it so that the network could not get a hold, and only and reinstate kind of this end-to-end principle. So all well that end-to-ends well? So maybe not completely, right? Because only a large effort by a transnational corporation with significant control of the network could make this evolution of QUIC and change possible and change the affordance structure. And QUIC development could arguably strengthen consolidation, and not directionality is still in place. So the equality of nodes is by no means restored. And of course, the operators are by no means pleased by this. And then in an interview with a senior uh, IETF person from IETF leadership, I asked, but how does this work then with permissionless innovation? And then they said, well, if you want to deploy a protocol, you need to play into some of the operators or vendors' earning models in order to get something deployed. That is simply the network reality nowadays. And if we then look at the parties that develop the internet infrastructure, they are getting fewer. And the number of people that are participating in the IETF is stabilizing. So that means that about the same amount of people are affiliated with a small number of corporations, which means that consolidation is also happening in the internet infrastructure. So when we listen to end-to-end permissionless innovation and openness, perhaps these myths are important for what they reveal and the genuine desire for community and democracy, but also for what they conceal, including the growing concentration of communication power in a handful of transnational media businesses. So the socio-technical internet architecture imaginary and its self-regulatory governance model that's anchored in end-to-end openness and permissionless innovation has not been able to safeguard freedom and equality among internet nodes or the researchers, or small companies or individuals to innovate on the internet protocol level. It's only possible for these transnational corporations to have a lot of control over the whole network and the resources to do all this testing and development. So permissionless innovation for the purpose of retaining openness had undermined itself and the end-to-end principle. So corporate interests have become a first-order consideration for protocols to be adopted and implemented. And political conceptions of the architectural imaginary are fading into the background, and more power is residing back not with the end users, but in the network itself. And whereas the importance and size of the internet architecture has only grown, and with it its societal implications, so these societal implications are not structurally considered, even though it has been asked and brought up again and again in organizations like the IETF. But it is also not easy. The IETF itself recognized it needed to do more work on security. It even recognized this in 1989 when security considerations became mandatory in the RFCs, the technical and policy documents of the IETF. But that doesn't mean that all security consideration sections are very long and thoughtful. Many are actually simply there are no security considerations here or copy pasted from other work. Similarly, when I, together with Corinne Kath, developed work on human rights protocol considerations in the IETF, the first human rights consideration that was produced in an RFC read like this, and here I'm asking you to read again with me the last paragraph of RFC 8492 called TLS password, which says, the most fundamental of human rights is the right to protect oneself. The right to keep and bear arms is an example of this right. Implementations of TLS password can be used as arms kept and borne to defend oneself against all manner of attackers, criminals, governments, lawyers, etc. TLS password is a powerful tool in the promotion and defense of universal human rights. I can tell you this is not what Corinne Kath and I expected when we were working on this, and it also shows that conception of human rights can differ quite widely, even though they are pretty well codified since 1947. So I've been trying to then tease that out a little bit, because initially I thought the problem with technology and human rights is simply that we haven't translated it properly to the technological environment. But when we did, we saw there was not a lot of uptake. So to understand that better, I want to look together with you at another part of the internet governance regime, namely a regional internet registry. And with that, touch with you on internet routing a bit, while we look at norm conflict in the governance of transnational and distributed infrastructures, the case of internet routing. So I think we should really look at internet infrastructure and also the routing infrastructure, because I think platforms, especially social media platforms, might be a bit overstudied. And whereas it is possible still to not to leave a social media platform, it is not possible anymore to leave the internet infrastructure. Even if you are not on the internet, information about you is communicated over the internet infrastructure. And it is very researchable still. And the internet infrastructure is often idealized or forgotten. So there are many books that say that the internet infrastructure has a generative structure and is therefore so unique and will be create prosperity and will not be prone to capture. Well, but it's also very commonly used for censorship and surveillance, and therefore it really deserves our critical attention. So the question is, how does norm setting and norm conflict work in such a distributed, complex, and transnational infrastructure, such as internet routing? So, and to look at this, to attack this problem together with you or approach it, we need to go into a bit of routing theory. And don't worry, please never say again that you're not technical, because you are. You're using technology every day. And if someone cannot explain it to you, then they probably don't understand it themselves very well. Internet routing, very easy. You all need a unique address, which is the IP address. We touched upon that earlier. IP addresses are connected to all these independent networks, these 70,000 networks that I've been talking with you about. These networks are called autonomous systems. And all these autonomous systems have a number. And these are called, nicely, autonomous system numbers. And these get assigned to companies or institutions. If you pay membership of a regional internet registry, which costs about 1,500 euros per year, you can get an autonomous system and an autonomous system number too. And then you also get assigned a block of IP addresses. And that block of IP addresses is then connected to your autonomous system. And then you can talk with and connect to other autonomous systems. And that is how internet routing works. And we'll look at that in a little bit. And this is then roughly what the internet looks like. But let's look at a bit more clear channel. So all these little islands, we see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. These are all autonomous systems. So a single computer can be an autonomous system or a group of them. Let's take the cute grouping at the left bottom. This is called AS1. And AS1 has got IP addresses 1 to 50. Then the second computer on the bottom row, that's AS2. And AS2 has IP addresses 51 to 55. And in the right lower corner, there is AS3. And AS3 has IP address 56 to 100. So if the computer with the IP address number 2 wants to communicate with a computer with the IP address 20, it will connect to the router of the autonomous system, and the router of the autonomous system will tell to the computer with that IP address, that's easy. I know where that is because that is inside my network. You don't even need to touch the global internet because here you can connect to your computer. Go make your connection, do your thing. Easy. But then it becomes a bit harder if the same computer with IP address 2 wants to connect with IP address 53. So IP address, a computer with IP address 2 talks to the router of the autonomous system, and the autonomous system says, well, thank you. This IP address you want to go to is not within the reach of my autonomous system. So I am going to look up in the routing registry to which autonomous system this other IP address belongs. So hey, that IP address belongs to autonomous system 2. And now I'm looking around and I'm seeing I am connected directly to autonomous system 2. So I'm sending it right over. Here you go, autonomous system 2. Can you bring this to IP address 53? Excellent, thank you. And then you have your connection going on. And then the third possibility is the even more difficult one, is when IP address 2 wants to connect to IP address 83, and the router is not directly connected to it, but via gossip. That means these IP autonomous system routers gossip with each other and tell each other how they can reach each other. And then AS1 has heard that he can connect to AS3 via AS2. So AS1 sends the packet to AS2, AS2 connects it to AS3, and there we are. We have all the stories of internet routing done. Easy does it. So, but then this feels like quite a flat world, right? Where everyone just routes to each other. But also in 2005, very important internet architects already understood that all these different networks, these different stakeholders that are part of this internet milieu, may have interests that may be adverse. And the accommodation of that tussle of different interests is crucial to the evolution of the network's technical architecture. But currently, as when Matthew showed in his beautiful PhD thesis that I recommend everyone to read, that routing decisions are currently made based on a mixture of efficiency, trust between people, and economics between organizations. So I wanted to see whether in these regional internet registries, of which there are 5 in the world, namely one for Africa called AFRINIC, one for the Asia Pacific called APNIC, ERIN for North America, LACNIC for Latin America, and then the RISO IP Européen for the rest of the world, which is Europe, the Middle East, and the former Soviet Union. And so I went to one of the oldest regional internet registry, which is RIPE, and thought, I'm going to see if we can bring more complicated norms that are not economy or trust, but other norms that see we can bring them into internet routing and design an experiment. But then the question, of course, was what values to express, right? So I wanted something relevant, something applicable, an existing framework, because I didn't want to come up with something. And it needed to be something transnational, because internet routing itself is transnational as well, of course. So, of course, there was the GDPR. And I know many of you are done with talking about the General Data Protection Regulation, but that is what we're going to do for the coming time anyhow. So why not here? So, and for those who you are not familiar, the GDPR is the EU law on data protection and privacy. It unifies data regulation across the EU, is applicable for inhabitants of the EU and EU citizens outside of the EU. So it's not just territorial, and it addresses the export of personal data outside of the EU and the European Economic Area as well. And then the second set of values, because I wanted two so I could also compare them, are the UN guiding principles on business and human rights that you human rights people are, of course, very familiar with. But for those who aren't, of course, human rights established in the Universal Declaration of Human Rights in 1947, but that was only an aspirational document, and these were only codified in treaties in the 60s, in the International Covenant for Civil and Political Rights, the International Covenant on Economic, Social, and Cultural Rights, the International Convention on the Elimination of All Forms of Racial Discrimination, etc. But then in the 70s, people also realized that it's actually not just states that have an impact on human rights. Of course, it's also companies, but there was not really a framework for that. So it took a lot of negotiation, a lot of development that brought about the UN Global Compact in 2000. You may not have heard of the UN Global Compact, but you've heard of the main term from there, which was corporate social responsibility. Corporate social responsibility concretely meant I have an oil spill here, I'll build a school there, so hey, I'm fine. So of course, this was slightly problematic, and this was also found out rather quickly. So then the UN Guiding Principles for Business and Human Rights were developed under the lead of John Ruggie, a Harvard law professor. And that framework had three pillars: the responsibility to protect human rights for states, the responsibility to respect human rights for non-state actors such as companies, and for those individuals impacted, there should always be an access to remedy. And the interesting thing was, is of course, many of the networks within RIPE already were subject to the GDPR, and some had signed up to the UNGPs. So I thought, this is great, right? So these are values that these organizations know, are subject to, are familiar with. So we only need to expect them technically, and it will be fine. So I developed two AS sets. And AS said, these were all the codes I needed to make. I just needed to put them in the database. And that meant that every autonomous system could become member of this AS set, and with that declare that they either were compliant with the GDPR or had adopted and implemented the UN Guiding Principles on Business and Human Rights. And what was then the nifty thing that we could do? Then people who route traffic could route preferentially or exclusively through members that are member of any of these AS set groups. So I thought that would be great, right? So then you can account for other values other than money and whether these companies trust each other. But unfortunately, right away, when I launched this on mailing lists during a presentation and in interviews, got outright rejected. And the big question was, of course, why? And for that, I tried to understand how norms work here. The norms are, of course, the collective expectations for the proper behavior of actors with a given identity, within a specific group, how we expect people to behave. And it always consists of identity, behavior, proprietary, and collective expectation. So what I found out is that the network operators that were part of the epistemic community of RIPE were expected to produce interconnection and do so in a voluntary bottom-up way based on collaboration and trust. And then the network's role was to facilitate and engage in interconnection through the BGP protocol, the Border Gateway Protocol. RIPE's role, the RIR, was to coordinate and facilitate interconnection through the RIPE database, where you could look up the AS and the IP addresses that were connected to it. Everyone has total control of their own networks, and interconnection between these networks is solely based on incentive structures and enlightened self-interest. So while I introduced the norm, people said and gave four reasons into four different sources for resistance. Namely, technologically, that the routers do not allow for preferential routing based on these AS sets. They simply don't do that. But also people said institutionally, the database is not meant for that. That's never how it was intended to work. Well, some people also said outright, this is not how it's done whatsoever. This is simply not how it's done. This is not according to our cultural code. This is not for the good of the internet. And some went with a straight economical argument. There's no incentive for us to do this. Why would we put work in this? So every norm that gets introduced that complicates or hampers interconnection gets rejected. And these can be laws such as the GDPR, ethical frameworks such as the UNGP, but also jurisdictions such as Schengen routing, that we would limit routing to a particular geographical area. So a lot of people say the internet doesn't recognize borders. Well, it might, Of course, the internet can recognize borders. It's just a choice not to. It is easier for global capitalism to not have to deal with borders, jurisdiction, and different laws. And even security measures get rejected because it limits interconnection and interoperation. And that's what these network operators are supposed to do. So the voluntary interconnection norm that I found instructs the epistemic community of network operators in RIPE to create more interconnection between and among networks and resist any norm or value that could hamper that. So here we almost come back at the beginning, where we see that the internet governance is guided by the internet socio-technical imaginary, anchored in the architectural values and process values such as openness, transparency, end-to-end, permissionless innovation, but that the socio-technical internet architecture serves to guide and facilitate the process of norm development and legitimize the current institutional ordering, even when they are concretely subverted in practice. And the infrastructural norm exists to instruct new norm development and evaluate norms that are being introduced. And the introduction or upholding of norms is successful if the candidate norms serve the interest of these significantly represented groups, or if the new norms are not in conflict with the overarching infrastructural norm of voluntary interconnection and interoperation. And with that, I think you should be able to understand this pyramid as I promised. But as a final thought before I round up, because we're already an hour in, is that what is the irony is that the internet governance regime is undermining its own authority because it resists norms that are in the interests of nation states. And this means that we're currently seeing an upsurge in rules and regulations of set by nation states, which we could describe as a multilateral internet governance regime that, together with this private multi-stakeholder internet governance regime, is making up the internet governance regime complex. And what is now to be seen is how these two regimes will interact in the coming years and how human rights can find a place in there. Thank you so much for your attention, and I am very willing and interested to take your questions.
Wonderful. Thank you so much, Niels. That was a fantastic talk and just really fascinating. And I feel like I acquired a ton of new technical knowledge. So that's really exciting as well. You did a great job of explaining some seemingly complex infrastructural factors in very accessible ways. So that's awesome. I'll just start by asking kind of a follow-on question to one of your concluding questions myself as the host, and then I'll move on to a couple questions that that are coming in from participants. And just as a reminder to anyone tuning in, to please put your questions in the Q&A or the chat, and I will pick them up there. And if you were tuning into the live stream, feel free to tweet them at us, and I will try to keep up with that too. But just to follow up with this question of where the power to set norms comes from, and why, for instance, the human rights norms that you tried to introduce were so readily rejected. I'm wondering how much of the norm setting power do you think lies in technical influence or sort of technical skill and prowess? So is this potentially an issue of corporations, for instance, exerting more influence over norm setting in the internet infrastructure domain? Is that in part because these corporations have quite a lot of technical power? They have a lot of coding expertise. They have a lot of influence. They can run the kinds of experiments, the A/B tests that you described. And as a result, because of that technical influence, they have more ability to kind of influence norms or shift norms. Is that something that you've seen in your research, as opposed to, say, exerting a kind of, let's say, softer normative power in the political realm by asserting, the importance of GDPR compliance without necessarily having that kind of technical influence?
Thank you so much for that question. And whereas economic power is definitely an important part, I think we should not, and really not, fall into the trap of economic determinism and say it's only about the money, because many of these engineers, and that I was so surprised, right? Because it is dominated by companies, and people know that, but they still say that these values are very important to them. And what I hear again and again and again and again is that they are trying to do what is good for the internet, right? But what is good for the internet for many people means more internet. So if we create more internet, more interconnection, more interoperation, there will be a better world. So for many of these engineers, the internet is good. And there was also someone from the GDR, the former Eastern Germany, who was a prominent internet engineer, also said, like, we did not have communication, and we thought that communication would really solve all the problems. That is their political theory of change, and also their whole constitutionalism of these complex bodies with their particular rules have been built around that. And I think they should also be respected, or at least like critically looked at with a lot of interest, that in these RFCs, it's not just technical protocols that are described. It sets organizational rules about which they debate endlessly. There is no voting for nation states. That's why they pushed out the ISO proposal. Now they wanted to run by rough consensus and running code. So up to now, decisions, when they are made, when the decisions are tough, decisions are made through humming in the IETF. So then you say, do you agree? If you agree with this proposal, hum now. And then up to 1,500 people in a room set out and hum. And they do that because it also affords people a level of anonymity, and allows them to give different amounts of agreement or disagreement without giving up their individual identity. And I think that's fascinating and interesting to look at. So I think we should, money definitely huge part, and that's what we also saw in that quote, like you need to play into the earning models, but trust relations, institutional configuration, and technological materiality all definitely play into that as well. Sorry, that was very long-winded, but
No, that's great. That's great. I'll take a question from one of our attendees, Giovanni, who says, it was a pleasure hearing this interesting seminar. I'm a PhD student, and I'm the support to management and communications activities for the ECPE project, enabling consumers to be prosumers in the energy transition era. And I have a question about the GDPR. What do you think about energy communities, smart grid, and the problem with privacy of each of us? I think we can speak about personal data, and we can rethink a way to manage this data in a smart system. Each app knows each life and each custom of life. I think that this is a big problem for our millennium and new smart life.
Dear Giovanni, really good question. And what I think what you open is a thing that I really hope that we will get at in the future, namely that we can start reconfiguring the infrastructures on which we build. Because right now the internet infrastructure is ossifying and is never questioned, even though things are about to change within 5G. So this is also an opportunity, but we should not be lured to choose between either Cisco or Huawei, because both are just two kinds of proprietary technology that are reordering our information societies without making the information about how they do that available. So I think we should, and I hope that we can build, for instance, on the right to science, which is also an often forgotten human right, that we can leverage that to understand how our networks work, and that we can redesign them, and that we have a multitude of networks that we can also configure ourselves. Because where it's going to now is that we're going to an era of distributed computing, where there's a lot of intelligence in the network itself. But even for us, it becomes even harder to find devices, because the friction that we now still have from interfaces is about to be removed, right? Because then we have all the sensors around us in our devices, and endpoints are the ends of the network become far more smudged, and then the network gains more power. So we should be able to configure the network and not have the network configure us, because that's concretely what is happening now. And just as one theoretically cannot outsource democracy, because then it's not democracy anymore, we should not be able to outsource our infrastructures either, because it's the very fiber, it's the very granularity, it's of our societies, lives, and democracies.
Thank you. I'd like to pick up another point that you made at the end of your talk, Niels, about the eroding legitimacy of the internet governance community, in part because of the fact, as you pointed out, that state norms are not really being integrated very effectively into internet infrastructure, and as a result, there's kind of a little bit of a normative crisis, it sounds like, in terms of the way that internet infrastructure norms are being set. And because I feel like this is quite relevant in the era that we live in, where expertise is kind of under attack, and there's a lot of criticism and suspicion around what you term epistemic communities, which I think is a really interesting concept. I'm wondering what you think are the ways in which epistemic communities like the IETF and internet and other internet norm setting entities, what they can do to reestablish legitimacy. What are the steps that need to be taken at this point to ensure that that legitimacy isn't completely eroded?
I think it's not that hard, actually, but they don't have the incentives to do so. And again, I don't think that the people doing their work in these communities are bad people. They are doing amazing work. They are making a network work that's giving us unprecedented possibilities, right? But there are no incentive structures for them to take societal consequence of their work into account. But these asks have been made since 2002, and they have been outright rejected. And they've been talking about it since the beginning, right? But they're not ready to complicate their question, and they are afraid that what is often cited, that it will politicize the discussions. But of course, the discussion is already heavily politicized now. It's just their politics, right? So and this is something that perhaps the change with the rise of the multilateral internet governance regime will change. So so there are different scenarios, but ideally, also we as epistemic community of scholars and critical thinkers. So one step back. So the coming 10 years is going to be the era of internet regulation. It's going to happen. We all know, so it's happening in China, it's happening in Russia, it's happening in Europe, it's happening in the US, it's happening in Brazil. It's happening, but we don't know how yet. And we're seeing, like the GDPR still took 15, 20 years to develop. The DSA, the Digital Services Act, is now up in 2 years. So it's also going faster and faster. So we need to kind of develop the nail on which the hammer of power is coming down. And then I really hope that we can bring in these structural societal considerations and the capacity to make these considerations into these standards bodies. Because as a global governance scholar, Jan Aert Scholte, once said, if the UN would be reinvented today, it would most probably look like internet governance. And whereas there are definitely things to be critical about, if I try to look for documents in the UN or try to see what their conversation was about, it's impossible to find, let alone partake in these meetings, right? So I think that that the internet governance regime definitely has great governance innovations, but that we can seek to improve it to help solve these issues, but also step out of internet exceptionalism and use the tools such as the UN Guiding Principles on Business and Human Rights to see if we can make it work for the internet, but then see if we can also use the model for other problems that we have that the UN and other models currently are not sufficiently solving.
In the interview-based qualitative interview work that you did, was it how difficult or easy was it to get people in these epistemic communities to talk about the values, to get really at the issue of values in terms of the work that they do?
They love to talk. And that is what makes that community great. Actually, you go there and you sit with the inventor of BGP, with the people who created TLS. So it was, and they are super eager to talk about it. They're also quite adamant about, and so they're not always. Corinne Kath wrote about that beautifully in some of her papers, and also a short piece on Hack Curio called Loud Men Talking Loudly, about how it's a very rugged culture, and how it's also like a very Euro and US centric male community in which some traits are more valued than others. But if you get, as happens with white men, if you give them a pedestal, they will talk, and that's what they did.
Okay, fair enough. I guess that's useful for your research for sure. It helps to discern sort of what those value structures are. So this past week, I've been teaching an anthropology of law tutorial at Oxford, and the last week was that I just ran was on internet norms and the regulatory and normative power of code. And so I'm sure that you're familiar with Lessig's classic argument that code is law. And so I'm wondering how you feel that your work in this realm is contributing to, or adapting, or amending, or refuting that kind of core claim that code acts in a legalistic, regulatory way. It sounds to me like one potential contribution is that you're kind of saying that norms are power. Is that kind of an addendum to code as law? How do you see those concepts coming into conversation with one another?
Yeah, it's complex. Well, that's the standard scientist thing to say, right? It's the, I'd say code are norms, and law is also norms, right? So there is a complex interrelation, but where Lessig equates them, I think that's a simplification that we should get behind, get over, right? Whereas it was an interesting moment to foreground the role of code in ordering our lives, and I tried to complicate that a bit by starting out by the excellent work of Keller Easterling, right? In the way that infrastructure in complex ways is providing orderings that go beyond laws, but then also building on Lee Starr by saying is that it's also relational, and so where law is clearly exercised from a state, I tend to go back much more to answer Lessig to an earlier thinker, namely Mann, when he writes about infrastructural power. And he writes that infrastructural power emanates from the state, but then also dissipates into civil society. And then the state kind of lose control over it. And then it's this power that we can shape and need to deal with, right? So and that's more how I see it. Also because code happens changes super quickly, right? And it also works in conjunction with other code in completely unforeseen ways, and also its workings change very fast. So understanding that by itself, I find already quite hard. And that's also like algorithms I find very hard to understand. I'm doing my best, but I also studied philosophy before this, and then try to understand ethics. And then you're mixing like two super complex concepts, and then you need to ask yourself, does it really help to put these on top of each other, or is it more obfuscating stuff and it just sounds good, right?
I think that's a question that all academics need to ask themselves on a regular basis. Is this making it more complicated, or does it just sound good? I'm kind of wondering, in this regulatory era that you feel that we're entering now, how much of this is kind of a state response to the lack of accountability that's perceived kind of in the way in which very critical norms about information are getting set in seemingly technical communities, where there doesn't seem to be kind of recourse for if something goes wrong, if there's a conflict, if something's not really quite working very well, where do you go in this particular ecosystem? And states are kind of reverting to what they know best, which is regulate in a legal form. How much of that is what's happening, and are there alternative solutions that you see kind of down the line?
Well, what I found to illustrate this best was that at a RIPE meeting, I think 4 RIPE meetings ago, there was a member from Europol who had partaken in the policy development process of RIPE, and then presented, and then this lady from Interpol presented that from Europol presented the proposal, and then a mic line formed of senior engineers who pretty much shouted her down, explaining how this is not how the internet works and how this is not done. And then I talked to the representative of Europol later, and she said, "Well, if you don't have it your way, we'll have it our way." And so it's like this fundamental disconnect between these communities, and also maybe a bit of uh, a misunderstanding, or how different perspectives of the world clash upon each other, right? Like the nation state and law enforcement agencies that, of course, like we go back to Olson and stuff to understand that, right? But also internet engineers really think they have created history, and they have, and that the infrastructure is their world, and they develop the rules in which it is run. But now it is like Raymond calls it, it's metastasizing into other regimes, and there's where you get these regime and norm conflicts, and that's where it then sees how is this being thought out, and that can be done infrastructurally, but it can go into standards and governance bodies. It can go through law, but law is also really slow, right? So and technology, and then it becomes a bit of a stone in the river, and technology rather quickly moves around it. But also the development of the internet, like international relations scholars like Madeline Carr have argued, also served a particular purpose, right? And in establishing a kind of rule and power over the world. And I think what we see now is that is also being seen by other nation states who do not necessarily feel comfortable with that. And in that sense, it is almost a full repeat. And I cannot recommend this book enough, Reluctant Power by Rita Zajac, that describes the rise of the US telegraphy system and the rise of policy making around there. And she uses capital, territory, and legislation. And it is almost a one-on-one description of the internet. So here again, we should also be very careful to not think of like everything is new and it's different than it ever was before. Like these global communication networks were always in the interest of nation states, power, and the military. And their history maybe not necessarily completely repeats, but it strongly rhymes.
Yeah, always a good reminder, I think that. So I think we'll probably wrap it up here just in the next couple minutes. But Niels, I know that your dissertation is available. If anybody would like to get kind of a much more in-depth view, would you like to share how people could access that?
Yes, I will put in a link now to the dissertation, and as that's the PDF. But for people who prefer the paper version, I have 2 copies that I'm willing to give to the first 2 people that email me with their postal address, and I will send it to your home, and it should then be there with you as the postal service will carry it.
Oh, wow, that's great. I didn't realize we were going to have a giveaway as part of the as part of the seminar. That's great.
For so long, you need to reward them,
No, this has been wonderful. Well, thank you so much, Niels. Is there anything else that I didn't ask you about that you would like to kind of give any concluding remarks on before we wrap things up?
No, again, I'm very thankful for you to organize me, Dr. Allman, and for the institutions to organize this. And I really look forward to future collaborations on these interesting and dynamic developments that we all do not know the answer to. And that's what exactly makes it so exciting. Thanks so much.
Excellent. Well, on that note, I think that's a great place to end here. Thank you so much again, Niels, for joining us. It's been a real delight to host you. And the seminar will be available on YouTube for viewing after the fact. So let's keep the conversation going online. And yeah, stay tuned for future seminars. We'll be starting up again next term.